So today we talked about the other three senses that I haven't covered. So sense of touch, sense of smell, and sense of taste. And so in terms of the sense of touch, I basically talked about that we have different receptors that are located all over our body to detect things like touch, temperature, pain, and something called proprioception, which is basically where we are in space at any given time. And in terms of touch, there's all kinds of ways that we can determine the kinds of touch that we are receiving. So we've got vibration, we've got pressure receptors, we've got flutter receptors. So all these things together make a pretty complete picture about what's going on. The left side of the brain is processing information coming in about the right side of the body, but how the information gets from one side to the other, it crosses at different points. It goes up into the cortex, and in the cortex, there's like a strip called the somatosensory cortex, where this information is integrated and it's mapped really in a beautiful way according to the area of the body. So all of the sensation from your hand would end up going up to the opposite side of the body. And it's very cool in terms of the organization because it's organized that there's more space in the cortex devoted to parts of your body that are more sensitive. And this is because if they're more sensitive, they have more receptors, and that receptive field then might be smaller for each one. So this is why we have areas like our mouth or our tongue or our fingers have a big representation in the somatosensory cortex, and then areas like the top of our thigh or our back have rather smaller representations in terms of how much space is devoted to it in the cortex. So then we moved on to talk about the chemical senses. So for the chemical senses, there are two, and that is the sense of smell and the sense of taste. And when you're talking about taste, there's actually only 5 tastes that we actually can detect. The tastes are sweet, sour, salty, bitter, and something called umami, which is like a meaty or a brothy taste. And so being that we only can detect these 5 different tastes, it's amazing how many flavors we experience when we're actually eating. And the reason that we can experience more than just the 5 is solely due to the fact that our sense of olfaction or smell is really important to the flavor of what we're eating as well. So we did this experiment where we have jelly beans and tons of jelly beans. So I've got this red jelly bean. If I do an experiment where I plug my nose up so I can't smell anything, and I chew the jelly bean up, I'm only gonna get one of 5 things I'm gonna get sweet. All right, I'm gonna release my nose. Okay, that's definitely cherry. I cannot just tell, there's no discrimination between the kinds of sweet that it is until my nose comes on board. The sense of smell is really important for this idea of flavor. And flavor is actually like this gustatory sensations we taste coming in. It's going to be smell, and also the way that it feels in your mouth will help you kind of have this flavor, this neurogastronomy of like experiencing what you're eating in a powerful way. So you can have a reaction to it of a like or a don't like. So the taste information goes straight into the taste buds. There's no such thing as different parts of the tongue that are specialized to have different kinds of taste. Like you can't only feel sour in the back of your tongue. But whatever those receptors are, it's very cool because they actually are cells that can respond to the chemical, such that the chemical binds directly to the outside of these receptor cells, and then the receptor cells send a signal straight up into the brain. So they were able to transduce this chemical energy directly into a neural signal right there on your tongue, which is, I think, super cool. And so then that goes up into the back of the brain. Olfaction, actually we have like 300 plus olfactory receptors. So we're able to discriminate with our nose a lot better than we can just with our sense of taste. We actually have really phenomenal senses of smell. A lot of what we smell, though, I don't know that we're actively processing into our experience, but it doesn't mean that that's not impacting our behavior nonetheless. So when you have a smell, it comes in as a chemical that's floating free in the air. And we're able to pick it up through similar receptor cells that are located on the inside of our nose that then go straight up to the front of the brain, where you have an area called the olfactory bulb, or the olfactory cortex. And this is kind of in the front of the brain, but it's underneath. And the smells can be processed there and really good at telling this smell from this smell, but we're not that great at using words to describe these smell experiences. And one of the reasons for this is because that olfactory cortex is separate from the rest of our cortex, from the areas that process the vision and that process language. They are connected, but they're not really great, like robust connections. However, we are fortunately able to kind of really tap into memories with olfaction. And so there's a very strong connection between the olfactory bulb and the hippocampus, which does learning and memory. And so this is why when we have a smell of like freshly cut grass in the summer, it'll take us exactly back to a memory maybe of childhood in a way that is pretty powerful. So those are the chemical senses, straight lines to the brain, basically, without a lot of relay through things. That is 3 different sensory systems in one day, which now has gotten us through all of our sensory systems. And we're going to move on to motor and some other kind of body functions, and then we're going to start talking about these big picture ways to integrate everything that we've learned. So thanks for listening. Join us every day in May for a new video.